Okay, so water is being pumped into a holding tank at a rate of 5 minus 5e to the negative 0.12 t liters per minute, where t is in minutes since the pump is started. If the holding tank contains 1,000 liters of water when the pump is started, how much water does it hold 1 hour later? Okay. Now, so here, this one, that's the rate at which the water is being pumped into. So I'm going to call that R of t. So that's going to be 5 minus 5e to the negative 0.12 t. So there are a couple of ways you can approach this, but we're going to, since we've been doing integrals, we're going to do it that way. You could find the antiderivative and use this as your initial condition, but it's a little harder. Not harder, I guess, just more work. But the better way to do it is to find the amount that was pumped in. Because if you find the amount that was pumped in and you know that it had 1,000 liters when you started, well, then you can just add that to it. So, well, how do you find the amount pumped in, the amount of water pumped in, if you have the rate? Well, by now you should know the answer to that. Ding, ding, ding. Exactly, you find the integral of the rate. So, okay, and then from where to where? Well, you need to know the time. So it says 1 hour later. Now here, this is really important that you do not go from 0 to 1, because you have to make sure that you know what are the units. What are the units? The units are, for the rate, is liters per minute. So that means that these t's represent minutes, and so this, the limits of integration have to be also in minutes. So since it's 1 hour later, well, then that would have to be 60 minutes. Okay. And so then you find the antiderivative, fundamental theorem of calculus. So this would be 5t, and then minus 5e to the negative 0.12 t over negative 0.12. And then you're going to evaluate this from 0 to 60. Okay. And so if you plug this in, you would get... I think I need a little bit more room here. So this is going to be 5 times 60 minus 5e to the negative 0.12 times 60 over negative 0.12. Let's make sure I didn't make any mistakes there. 60, 5 times 60. Okay, good. All right, and then minus, plug in 0. Now you might be thinking, oh, well, that's just 0. But no, right? It's not going to be 0, because it's 5 times 0, and then minus 5e to the negative 0.12 times 0. I'll put that one as 0, over negative 0.12. And e to the 0 does not equal to 0 at all. So when you you do all that stuff, you would get this is equal to about 258.36 or so. Now, this isn't the amount of water that you have. This is the amount of increase that you had in water. And, of course, if it would have been negative, it would have decreased. So it would have meant that it would have been pumped out. But since you started off with 1,000, then you have a total amount of water is 1,258.36. What are the units? Liters. And that's it. Okay, so this question has a couple of tricky aspects to it. Basically, what we have is that the graphs below, right here, represent the velocity of a particle moving along the x-axis from 0 to 5. So all of these are fixed axis from 0 to 5. And now we want to figure out, based on that, which one of these has each one of these properties. Now, notice that the questions are based off of velocity, and the questions are about acceleration and position. Well, and velocity as well, but okay. So let's get started. So here the first one says which one has. Now there could be one of these that has more than one of those properties. So there's more than one. There could be more than one correct answer. Okay, so the question is which one has constant acceleration? So the question is, well, constant acceleration, what does that have to do with velocity? So for acceleration to be constant, then that means that acceleration looks like a horizontal line, right? So think of it as acceleration is the derivative of the velocity, right? So what does a function look like when it has a constant derivative? Which one of these has a constant derivative? Well, if you think this one, you are ding, 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 correct. Okay, now, which one of these, so let's go on to the next one, ends up farthest to the left of where it started? Okay, so remember that, so these represent velocity, and farthest to the left, remember that positive velocity means that you're moving to the right, and negative velocity means that you're moving to the left. So in a sense, what this is asking is which one has the most negative velocity. And so if you compare all of these, well, you would have to say that it's this one, right? Because this is the one that spends the most time down here. So all this time when it's negative velocity, all this time our particle, which could be, I don't know what it could be, but it's moving left. Okay, now the next one, trying to find a color here, which one ends up farthest from its starting point? So it doesn't matter if it's left or right, which one ends up the farthest from the starting point? Okay, so farthest from the starting point means, this is the largest, in other words, the largest displacement. The largest displacement. So, for example, this one would be not farthest at all. It would be the closest to a starting point, right? Because the time that it spends above is about the same time that it spends below. So this is kind of like it's going forward and then it's going backwards. So farthest from its starting point would mean that it has the greatest area underneath the velocity. So out of all of these, it's not 100% clear. I would bet on this one that the area underneath this curve right here is greater than this one. But notice how you've got this little chunk right here. So, I mean, it could be this one. You would have to actually calculate it because they look kind of close. But this one, for example, this one moves forward. So they kind of offset each other a little bit. And so that's why I think this one is a little bigger. But it could go either way. Okay. Now, the next one, which one experiences the greatest initial acceleration? Okay, so what aspect of the graph are we looking at? Notice these are velocities. So the acceleration, that's the greatest initial acceleration. That means that if we're looking at the velocity, we're looking at the greatest initial derivative. So out of all these, which one has the greatest initial derivative? Well, it would have to be this one, right? Because if you look at the slope of the tangent line right there, that's the steepest line. So this one would be D. Okay. Now, which one has the greatest average velocity? Okay, now this one is quite tricky. The greatest average velocity This one is, it seems a little counterintuitive because, I mean, the greatest average velocity basically means that which one traveled the farthest. Those two are the same because if you think about it, that makes sense. If your time interval is the same for all of them, then the average velocity is just the difference between it's the slope of the secant line between the starting point and the ending point of all of these functions. Now, the problem here, though, is that you're not looking at the secant line of the velocity because you're trying to find the average velocity. You would have to look at the secant line of the position. So, but instead of looking at that, since all you have is the velocity, then you're looking at, well, which one traveled the farthest based on where it started, which one traveled the farthest. And so since it doesn't really matter where each one started, you're measuring each one from their own initial starting point. But this question is basically exactly the same as C. Which one ends up farthest from its starting point? And so the answer to that is going to be the same one as the answer for that question. Now, that isn't the same question as which one has the greatest average acceleration. Now you're talking about the secant line of the velocity, because the acceleration is the rate of change of the velocity, right? And so this you're going to be looking at then, since you're looking at the average, then you're looking at the secant line of the velocity. So then you look at, okay, the starting point and the ending point for all of these. Which one has the greatest change? Well, this one doesn't, because that's 0. This one's 0. This one is pretty small. I would probably bet on, well, not probably, I would definitely bet on this one because this one has negative acceleration. So that would have to be this one right here that has the greatest average acceleration. So those two, that's a little tricky, but think about it and it'll make sense.